using quadratic equation. There are conditions in a given problem which, when translated to the equation form in one variable, lead to a quadratic equation and two answers are obtained. Examples: if the square of a number is added to 3 times the number, the sum is 108. Find the number. So let x be the number. So we have x squared plus 3x equals 108. After that, let's transform this one into standard form. So we have x squared plus 3x minus 108. Then, factor. So the factor of x squared plus 3x minus 108 is quantity of x plus 12 times quantity of x minus 9. After that, equate them to 0. So we have x plus 12 equals 0 and x minus 9 equals 0. Then, to solve this one, we will use additive inverse by adding both sides of negative 12. So we have x plus 12 minus 12 equals 0 and x minus 9 equals 0 minus 9. 0 plus 9, I mean. So we have x plus 12 equals 0. So we have x equals negative 12 and x equals negative 9. So to check this, we will substitute the value of x. So we have first is the value of x, which is 9, which we have 9 squared plus 3 times 9 equals 108. 9 squared equals 81 plus 3 times 9, we have 27 equals 108. So 81 plus 27 equals 108. So this value is correct. So for negative 12, we have negative 12 squared plus 3 times negative 12 equals 108. So negative 12 times negative 12 equals 144. And 3 times negative 12, we have negative 36. So 144 minus 36 equals 108. So this is correct. B. A rectangle has a perimeter of 30 cm and an area of 54 cm squared. Find its dimension. In the formula for perimeter, we have P equals 2L plus 2W. Let L the length of the rectangle. Width equals 30 over 2 minus L, or 15 minus L. To substitute the value in the formula of L times width equals area. So we have L times, which is the value of width is 15 minus L equals 54. Then, let's distribute. We have L times 15, we have 15L. L times negative L, we have negative L squared equals 54. After that, let's transform them into standard form, then factors. So we have quantity of L minus 9 times quantity of L minus 6. Therefore, the length of the rectangle is 9 cm and the width is 6 cm. So we have one side of a rectangular field is adjacent to the river. The other 3 sides are to be enclosed with 160 meters of fencing. What dimensions of the field will give the maximum area? So let x represent as our width of field and the y as the length of our field. So we have 2x plus y equals 160. So to transfer the 2x to other side, so we will use additive inverse. So we have y equals 160 minus 2x. Then we have area equals x times the value of y, which is 160 minus 2x. After that, we will distribute the x to the 160 minus 2x. So we have x times 160 equals 160x, and x times negative 2x equals negative 2x squared. Or our answer is negative 2x squared plus 160. So to solve for x, we will use negative b over 2a. So we have our a is equals negative 2 and our b is equals 160. So we have 160 divide 2 times the value of a, which is negative 2. So we have negative 160 all over 2 times negative 2 is negative 4. And negative 160 divide negative 4, the result is 40 meters. So, to solve for y, we will use the value of x, which is the 40. This, the value of x, the 40. So, we will substitute this one into the value of x. So, we have y equals 160 minus 2x. So, substitute the value of x, which is 40. So, we have 160 minus 2 times 40. So, negative 2 times 40 equals negative 80. And 160 minus 80, we have 80 meter.